Welcome. In this video I'm going to be taking a look at this Togo Power Advanced 650 power station. So this was provided to me by the distributor, but they're not compensating me for this video and they're not reviewing it before I post it. If you find this video helpful and you want to purchase one of these, I'll put a link to it in the description on Amazon, and if you use that link it helps me out a little bit and doesn't cost you anything extra. So this is a 634 watt hour power station. It's rated at 500 watts with 1000 surge. There's some different icons on the side of things we can do with this. Let's look at the other side. Here it says USB PD 60 watt, Apple devices charging available. Has a wireless charger, 10 watt quick charge, has an LED and flashlight, and it's pure sine wave. So let's get this open. Here we have the manual. So I'll read through this and go over the features. Pull the foam out. Actually going to move this off my bench. There's the power station. And here's the accessory box. So inside of here we have the charger. So that uses a standard style power cable, so we can plug that in there. The other side uses this barrel jack. Input on this is 100 to 240 volts at 2.5 amps. Output is 24 volts at 5 amps. We also have a 12 volt car adapter, and we have an 18 to 24 volt solar panel adapter. So the first thing I'm going to do is charge this up. So there's an input port on the front here. I'll plug into it, and then I'll plug into the power outlet. Okay, it's turned on. There we go. We have a backlit LCD screen here. It says the current charge is 59%. Input is 99 watts DC. And if I look at my power meter I have this plugged into, it's drawing 112 watts. You are going to have some loss there. That's normal. And it says it's 2 hours to complete the charge. So I'm going to let this charge up and I'll read the manual in the meantime. And then I'll come back and we'll go over the features of this. Okay, so I have this charged up now. And it has this read before use card. It says read the manual, and I'll be going over some things in the manual, but you should still read the manual yourself. It says keep away from water and fire, and it says charge it as soon as possible when you get it. So let's take a look at some of the features. It's flat on the top and has this handle that comes up, and there's a little bit of rubber under here with some grip, so it's really nice to hold. It feels nice. I did weigh this and it was right around 16 pounds. Then this is a hard plastic here. It has these kind of rubber bumpers on the corner. On all four corners. We have a vent on that side, a vent on that side, and there are lines in the back, but that's not a vent. It does have some specs on the back, and it has some warnings on the bottom. On the front we have an LCD screen. We have DC outputs. So this has barrel jack outputs and a 12 volt socket like a car, and that's 12 volts at 10 amps. Then here we have 3 USB type A ports and 1 USB type C port, and that's a PD port, and the others are QC3. So you could use these to charge up things like phones, laptops, Chromebooks, MacBooks, Nintendo Switch, many devices you could charge with this. And having that USB power delivery port is really handy because you can just direct charge something like a MacBook or a Chromebook with this. You don't have to have a plug-in adapter, so that's going to be more efficient. Then we have a light on the handle right here. That's an LED light. We have the DC input here, and this is where you charge with AC. You can charge from a car or you can charge from solar panels. You use this same port for all of those. We have 2 AC outputs here. So these doors flip open to reveal the AC outputs. We have a flashlight on the end, and on top we have a wireless charger that's Qi compatible. So next let's look at the buttons. We have the power button. This is the DC outputs button, the USB outputs button, the AC outputs button, and then we have the LED light button here. So the power to this is off, but we can use this light. So I can press the button on the handle and the flashlight is on. I can press it again and we have this light on. We can press it again to turn it off. Now if I hold this down, there's going to be a flashing light here. It goes into emergency flashing mode, so it does an SOS. So now I'll turn the main unit on. I'll press the power button. It says the battery is at 100%. So if I want to use the DC ports, I'll press DC. You'll see DC shows up here. If I want to use USB, I'll press USB. USB shows up here, and then if I want to use AC, it will show up here too. So the reason you have to turn these on is because there's circuitry involved with this to run these things. And if you're not using them, you don't want them to drain the battery. Specifically, the AC uses a sine inverter, and those have some overhead to them. You can see it's drawing 7 watts. So if you're just charging a laptop here, there's no reason to have your AC ports on. Now, of course, if you're using your AC ports, then you're getting usage out of that overhead. But if you're not using them, it's best to leave those off. So I'll press this again to turn it off. So as you can see, this is very easy to use. You just press the button next to the port you want to use. So I will plug some things into this in a little bit so we can see the display how it works because it will tell you how much time you have on the battery using certain devices. So if we look in the manual here, this talks about some specs. It has 18650 lithium cells. Capacity is 634 watt hours, 22.2 volts, 28.6 amp hours. Has the dimensions on here, the weight, and this is important here, it's the charging temperature is 32 to 104 degrees Fahrenheit or 0 to 40 degrees Celsius. So like with any lithium batteries, you don't want to charge these below freezing temperatures or if the batteries are really hot. Then the discharging temperature is 14 to 104 degrees Fahrenheit or minus 10 to 40 degrees Celsius. So lithium cells can be pretty robust, but they're not great with extreme temperatures. So this isn't something you'd want to keep in your car below freezing, or you wouldn't want to take this out to the beach on a hot day and leave it in the sun. If you were to take it out to the beach on a hot day, just put it under a tent or something. You can get like a beach tent and put it under there to keep the sun off of it. Or if it's in your car, put it in a low point in the car so it stays cooler. You wouldn't want the sun shining in the window right at this. But extreme temperature can degrade the batteries in a lithium battery. And then here we have the charging inputs. The PV input is 16 to 22 volts. The DC input is 12 to 28 volts. 100 watt max. And then the specs for the outlets, or the AC outlets, are 2 by 120 volt, 60 hertz, 500 watt, 1000 watt surge. So that surge is nice. Certain loads will peak like when you turn them on, like motors. So it's nice to have that surge there. So if the motor itself draws below 500 watts but the surge goes over it, this can handle it. Now if you have continuous of that, it will likely shut it down. But it's nice that it has that feature. And then the 12 volt socket is 12 volts at 10 amps. DC ports is 12 volts at 10 amps. The USB-A ports are 3 by 5, 9, or 12 volts up to 3 amps, total of 54 watts max. The USB-C port is 1 by 5, 9, 12, 15, 20, 3 amps at 60 watts max. So you're going to get really good charging out of this if you hook it up to something like a laptop. The wireless charger is 10 watts max. The LED light power is 0.5 watts for the light and 1 watt for the flashlight. And then it gives some sample loads here. You can read through those if you want, but I'll be doing some testing too. So here's some other information. It does support pass-through charging, so you can have this plugged in and plug something into it. So if you know a storm's coming, you could plug your computer into this, plug it into the wall, and use it sort of like a UPS. This talks about overload conditions and such. And then there's cleaning, storage, maintenance, and recycling. So I'm going to connect a device in here. I have a box fan. If I run it on low, it's around 70 watts. So I'm going to take this energy monitoring device. I'll plug this in here. I'm going to plug my box fan in here. And I'm going to let that run until the battery's depleted, and then I can tell how much capacity this battery has. So I'll do that now and I'll come back with the test results. Okay, so I hooked a fan up to this. It was around 70 watts draw and it is empty here. So I need to plug my power meter in so we can read it. I did switch power meters here. I was having trouble with the other one, so I actually started over. But if we go down through here, we can see this drew 0.58 kilowatt hours, which would be 580 watt hours. So this is rated at 634 watt hours. So if we do the math on this, we were able to use 91% of the capacity of this. So the reason being is that the AC inverter is going to take some power. It's not 100% efficient. But I would say that's very efficient, so that's pretty impressive. So we can also look at the time here, I think. So this ran, it was just a few minutes under 9 hours. This was going for a couple minutes while I was talking here, but it ran that fan for almost 9 hours at around 70 watts or so. Okay, so I have this charged back up, so now we can use it for powering things. So here I have an iPad. I can plug my lightning cable into the iPad, and I have USB cable here. So I could plug this into a power adapter and plug it in one of the inverted ports. And I already turned this on with the power button, and I could press this here, and this will charge it, and that works perfectly fine. But this is not the most efficient way to do this since it does have USB ports. So what you want to do is use these USB ports. That way you're not doing the conversion from DC to AC to DC again. It just converts it right to USB, so that's going to be more efficient. And I want to turn off the AC ports, turn on the USB ports. And here we're charging. So this also has USB Type-C, so we can use a USB Type-C cable to charge devices that support power delivery. I have a switch here. I can plug that in. So now I'm currently drawing, looks like about 5 watts. So these devices are charged, but if they were low, it would charge them better. So using that USB Type-C is great for charging laptops and such because you're going to get very efficient charging. If you use your power adapter in here like I did with the cell phone, that's going to give you less efficient charging. If you can plug this directly in with a USB to USB cable, that's your best option. So if you work from a vehicle and you want to have power for a laptop, that's what you want to do. Now if you have a traditional laptop and you have to plug into the AC power, you can also do that. And since it has 4 ports, you can charge 3 traditional USB devices and 1 USB Type-C. So then we have the DC port. I have an item someone might have here. It's an inflator for like an air mattress. I can plug that in here. Now if you're camping or something, you can plug this into your car to air up your air mattress. It can be a huge pain because your car might not be where your air mattress is. This thing you can take right into your tent, hit that DC button, and we can turn the inflator on. Now I muted that audio there. So this is running at about 120 watts. So it's essentially maxing out this socket here. But I can feel a tremendous amount of air blowing out of here, so it's very powerful. Another thing you would have to do is start your car up to run this from a car. Having the power bank here, you just turn on the DC port, and you're good to go. So we're done with DC. I'll turn that off. Next, we'll try AC. And I have this Dremel rotary tool. I'll plug it in to the AC port. Turn the inverter on, and now I can run this rotary tool. So I'll turn this on low here. Okay, so if we see here it says it's taking 24 watts, let's actually turn off the USB ports, although I don't think that's taking a whole lot. So we're drawing about 22 watts here, and what this is saying here is it can run that for 28 hours on this top line. So if you plug in something like a fan, CPAP machine, this will give you an estimate of how long it can run those devices, given the power it's using. So it's not super helpful for something like a drill. If you plug a corded drill in here and you're drilling a hole, you're going to be using some power for a few seconds and then you're going to turn it off. So this is not going to be able to calculate from that. But if you're using something that's using constant energy, like if you plugged a TV in here, you could tell how many hours you could run a TV from this. So reading through the instructions and such, they say that the efficiency of the inverter is 85%. So if you take the 634 times 0.85, I think it's 540 usable watt hours out of this. So if you have a device that can run off of DC or AC, it tends to be more efficient to run off the DC. So this inflator here runs off 12 volt, but I've seen inflators before that'll run off 12 volt or AC. So in that case, you'd want to run it off the 12 volt. Same with something like a CPAP machine. To get the most energy efficient usage out of this with a CPAP, if you can get a 12 volt adapter, that's the more efficient way to go. You can also wirelessly charge here on the top. So I have an iPhone 13 mini, power station on, and now I can set the phone here. And as you can see, it's wirelessly charging. So that's the Togo Power Advanced 650 portable power station. So a device like this is very versatile. It's great for powering all your devices since you have DC, USB, and regular 120 volt outlets. And also this has wireless charging. And if you turn this on, the wireless charging is just enabled. You don't enable any of these here. You just set your phone on here and it starts charging. But these can be good when you're camping, if you're doing van life. So this could also be good if you're just traveling. So if you take this camping, you could run a CPAP with it, a fan, you could run lights off of it. I know at the campground, I see a lot of people watching a game on the weekend, so you could plug a TV into this. This could also be used in an emergency situation at a home. So if your power goes out, you could use this to power a refrigerator, medical equipment. You could plug a TV in it so you could watch, say, for severe weather, things like that. You could certainly plug lights into this too, especially with modern lights being LED. You could run one of those for a very long time. If you ran a 100-watt light bulb on this, it would drain it in a couple hours. But if you ran a real high efficiency LED in it, it could run it for a whole day easily. So that's all I'm going to cover in this video. If you have any questions, please leave them in the comments. If you like this video, please click like. If you haven't subscribed to my channel, I'd appreciate it if you could do that. And thanks for watching. Until next time, goodbye.